100,000. A huge number. What does it have to do with MVTec? And how does it connect to MVTec Research? Well, last year, on November the 14th, we received an email saying that the download links to one of the datasets we published did not work anymore. So I got curious and reached out to our cloud service provider. And they told me that these download links were blocked automatically because there was too much data traffic going on the download server. 100,000. Over 100,000 times, our MVTec Anomaly Detection Dataset has been downloaded until today. You may now ask yourselves, what do the datasets we publish at MVTec have to do with you, our customers? I can already tell you right now, a lot. And I hope that after the next 15 minutes, you will know that too. But let's start with a simpler question first. What does it even mean to do research at MVTec? Research at MVTec means to create innovations that happen between customer needs and science. And as a technology leader, we thrive to be innovative, to provide you with state-of-the-art technology. And this, I can tell you, does not just happen by hosting an innovation day. We need to be connected to all places where innovation might happen. And this is not only us, MVTec, and neither is it just you, our customers, or the industry. Most of the innovation still happens in science. Just to give you one example, at last year's Prime Computer Vision conference, the CVPR, nearly 3,000 papers have been published. Every paper is roughly one idea. Not necessarily a good one, but still, an idea. So science is definitely one place you want to be when it comes to innovation. And of course, we at MVTec also want to make use of this source of innovation. However, there is one thing you need to know. Scientific innovation is not equal to industrial innovation, to the innovation you need. You do not just need state-of-the-art performance, but state-of-the-art industrial performance. In simple terms, you need solutions that work and can be deployed in real life and not just on paper or using a high-power GPU. And this is exactly the point where we at MVTec Research come into play. On the one hand, we look at all the ideas and trends from science and ask ourselves, could this also work in one of our customers' use cases? On the other hand, we do not only want to get trends, but also to set trends. To actively set trends with the problems you are facing in mind. Because waiting for industrial trends just to happen won't work. Why should anybody in science care about the problems of the industry? How should they even know about these problems? Well, they might go to the MVTec website, have a look at the datasets we publish, and think, hey, this is actually an interesting topic to do research on. And eventually, this research from the scientific community flows back to us at MVTec and helps us to create a solution that can also be deployed in your applications. So state-of-the-art industrial performance and innovation is what you get out from us doing research at MVTec. But for us, doing research is not only about innovation. It's also a lot about inspiration. To get the best ideas for new product features, we are receiving on all channels. Certainly, it might be one of you who says, this would be really helpful for us. Can you do this? Or, I see a possible improvement for this technology. What do you think? And of course, we hear these needs and wishes you have and consider them very carefully in our decisions about what's next for us at MVTec Research. Likewise, we listen to science. But here, it's not only about the major trends. If we only follow the major trends, we would right now only do research about ChatGPT-like models. Let's call them all-knowing deep learning models. But do you necessarily need models that know everything and anything? We believe you need industrial models, models that can be deployed under real-time conditions, even on edge devices, and that adhere to your specific data privacy regulations. And often, you still need classic rule-based machine vision algorithms. And good luck with finding a paper on classic machine vision these days on a major scientific conference. If you find one, this is not a trend, it's an outlier. But these outliers are exactly what we are looking for when visiting a conference, because we know these outliers might be relevant to our customers, and so they are also relevant to us. Last but not least, believe it or not, sometimes ideas even have their origin inside MVTec. No, seriously, there are around 300 machine vision enthusiasts working at MVTec, and it's not only the research department who is allowed to have an idea. So you might be able to imagine this one colleague on a Friday afternoon at 4 p.m. telling you, I just had an idea. What do you think? Can we still quickly try it before the weekend? And especially within the research department, we really try to be that kind of colleague. But luckily, as said, we are part of an even greater team of machine vision experts that know exactly what our customers need. So you see, an idea that is worth to be researched because we believe it can create benefit for our customers can come from basically anywhere and anybody. There is no blueprint for having such an idea. But what happens next when we finally have this idea? The idea, wherever it may come from, certainly finds its way to us sitting in the research department. And inside the research department, we're not talking about ideas anymore, but about research questions. And to answer such a question, we need the right data to build a solution upon. If such data exists, for example, you share it with us and explicitly allow us to use it, great, let's go and find an answer. But if not, we need to create this data first. And sometimes we have to dig for this data with our own bare hands. For example, to me, this means going into a room without windows for quite some time and creating a dataset such as the new anomaly detection dataset. Once we have the data foundation, we can start thinking about the solution. And again, collaboration and exchange is what fosters real innovation here. So throughout both processes, data collection and solution development, we listen to what you have to say as our customers, for example, when we provide you with a prototype. And we exchange with others from science who might have a similar or at least a related problem. And we happily invest all these efforts in exchanging with you and others, because ultimately, we want to have a solution that really fits your needs. Now let's assume we found the perfect answer to the research question. Is our job at MVTec Research already done, and we can all go on holidays and just let our product development team do the rest? Maybe a quick question before giving the answer. Who of you in the audience has seen the movie Inception, the one with Leonardo DiCaprio? If you've seen it, please raise your hand. Okay, I'd say this are more than 50%. Nice. For those who did not see the movie, don't worry, I'll explain it. Or for those who do not remember the movie well. There is a scene inside this movie, Inception, where two people are permanently walking up the same staircase, over and over again. They are walking up an infinite staircase. It looks similar to this one here. And this feeling, the feeling of permanently walking up to another top, this is exactly the feeling at MVTec Research, because we know we're not done yet at all. We know that existing solutions usually reveal new challenges. Once the solution finds its way into your applications via one of our products, we get to know these challenges sooner or later. So here we are again inside the MVTec Research department, chasing the next level solution, solving the next level problem. And from the outside, this might sound a bit frustrating, having to do it all over again. But inside MVTec, this closed loop has a tremendously high value. The only way for us to get better is to know about the problems our customers are facing when using our technology. And I can tell you, sometimes we are quite surprised about what you are doing with the tools we are providing. You can be quite creative. And this is great. We want to know all the edge cases. We want to know what you have in mind when using our products, and we want your feedback on our solutions so that we can improve them further. And this is not something our marketing department told me to say. This is what I do at MVTec Research, because I do research on anomaly detection. And anomaly detection is quite a success story for us, not only in industry, but also in science. Anomaly detection is a great example of creating real customer value based on the exchange between science and industry that is happening through MVTec. In HALCON, it all began in 2019 with the first version of deep learning-based anomaly detection. This was our first approach to detect unknown defects only based on good data. So actually similar to us humans, because we as humans know what a product should look like. So we also know how a product should not look like. We can detect the defect based on a known reference. And at the same time, a dataset that already helped to create the first method, the MVTec Anomaly Detection Dataset, was also released to the public. And this dataset really boosted innovation in anomaly detection research. With over 100,000 downloads, it's nowadays the ultimate benchmark dataset for scientific anomaly detection research. It literally created this field of research, industrial anomaly detection. Likewise, the MVTec LOCO-AD dataset opened research on the detection of so-called logical anomalies. There was no logical anomaly detection before that dataset in science. MVTec really was the trendsetter here, again. So these two datasets created a lot of echo within the scientific community. And consequently, more and more ideas were developed how to handle anomaly detection based on deep learning. And during the development of our own method to solve these datasets, this echo also helped us to generate ideas that work on your applications. And finally, with HALCON 2205, the global context anomaly detection, which is also known as GCAD, was then released. Later, GCAD was further improved in performance and speed, and a nice usability feature, the restriction of the domain during inference, was added. So you can see, a lot has already happened in anomaly detection, and we are not done yet. In fact, we have already taken the first step of the next iteration. We created the MVTec AD2 dataset. The MVTec AD2 dataset is a collection of challenging industrial anomaly detection scenarios that were derived directly from your applications and your feedback. So it might even be that one of your support tickets was the inspiration for a certain object category here. But just to be crystal clear at this point, we never use real customer data in the datasets we publish. We just recreate the problems. So inspiration really means inspiration. Unfortunately, right now I cannot go through all of the challenges included in the dataset in detail, but low contrast, transparency, small defects in large images, changing lighting conditions. Believe me, we made the defects in the dataset really hard to detect, as in the real world, because you know the best that the real world usually is a hard world with hard problems and not a laboratory. So only a challenging dataset will allow us to do meaningful innovations for you. But why are the scenarios I just talked about so hard to handle for anomaly detection algorithms? Let me give you some insights into the algorithmic side based on two concrete examples. First example. Let's consider high variability in the defect-free data. Here, fruit jelly is a perfect example. When producing this fruit jelly, you randomly put chunks of different fruits inside a cup, add some jelly, maybe stir a little, and that's it. At least that's how we did it in my kitchen when we prepared the samples for the dataset. You will never find two jellies that look exactly the same. Of course, we expect that our anomaly detection system can generalize to this variability to a certain extent. But in this case, the distribution of normal data just gets so wide that it is now significantly harder to learn it. Is it an anomaly or just a new configuration you have never seen before, also not in a similar form? Please, try for yourself. Can you detect an anomaly in the images in the center? Look closely. Who has found one, or even two? Maybe 3 or 4? Yeah, some are hesitating. If you find it challenging to differentiate between allowed and unallowed variations in this example, this is exactly what the anomaly detection algorithms also struggle with in such an application. Still, we definitely want them to work. On the left-hand side, there's a piece of metal inside the jelly, so you better have a good dentist or a really strong stomach. And on the right-hand side, you will not only enjoy this jelly as a sweet and refreshing dessert, but with the salty surprise of a piece of pickle. I don't know about you, but this would not be to my taste at least. So even if the normal data is subject to enormous variation, there are plenty of good reasons that our anomaly detection system still detects real anomalies reliably. Reliably and in time. Time is a precious asset in production. If your anomaly detection system cannot keep up with your production rate, this is not acceptable. And especially small defects in large images pose a major challenge here from an algorithmic perspective. For example, in this image of a piece of sheet metal, which is around 4,000 by 1,000 in width and height, there are defects contained in the new dataset that are roughly as small as 30 by 30 pixels. This is only 0.01% of the overall image area. And we know that such use cases and even smaller defects and even larger images exist in practice. And they are indeed challenging. Because certainly, you cannot just downsample this image by a factor of, let's say, 8, and still expect that every defect is still visible at this resolution with respect to its surrounding. So we need strategies. Strategies to handle these issues. Strategies to provide a decision about whether or not there is an anomaly in this image in time, even for such tiny defects. Efficiency is as important to us as it is to you when developing a new solution. So given these two examples, I hope that you have seen that we designed the new dataset to reflect the problems you are having, challenging use cases from your applications. And now that we know these challenges, we're finally back inside the circle of innovation, back at MVTec Research. Because now it is on us to solve these challenges for you. And certainly we will solve them, not only on our own, but with your help and feedback, and with the help and feedback from the scientific community. Two worlds we actively engage with at MVTec Research. Because in our opinion, this is exactly the way to drive industrial innovation forward. We do not only want to participate in the process of innovation, but to actively shape it. To actively shape it with our customers in mind. At MVTec, we are chasing real progress in machine vision. And real progress can only happen through collaboration with both worlds, the world of industry and the world of science. Because only an open exchange of needs, wishes, and ideas will finally make it possible for us to develop a solution that really fits your needs, a solution with state-of-the-art industrial performance. And fostering collaboration and exchange for the sake of innovation is exactly what we do at MVTec Research, for example, when we publish datasets. And as you've seen for anomaly detection, this approach finally creates real value for you, our customers. We invest in the circle of innovation, create new datasets, and do research so you don't have to. And if you now have any particular anomaly detection application in mind you'd like to talk about, please feel free to come to me. I'll be here throughout the whole day. In any case, let's walk the infinite staircase together and reach 100,000 downloads with a new dataset again. Thank you.